Okay, perfect. So we started the recording of the meeting. Good morning, everyone. As I said, my name is Christian Galletta. I'm working for Federalness Project Officer and here representing the Green Island project. This webinar is co-organized, as you know, with the Clean Energy for EU Island Secretariat. And the aim of this webinar is to present to you some best practices from islands, from geographically different islands, because we are aiming at representing, bringing to you examples from the Baltics, from the Northern Sea, from the Atlantic, and also presenting to you the challenges and the opportunities for hydrogen's uptakes in islands. So without any further ado, I will start by going very quickly through the agenda with you. So as you know, we will start with this introduction, and then we will have a presentation from Jan Cornil and Stefano Barberis. They will both represent the Clean Energy for EU Island Secretariat, one as the coordinator and one as a partner of the Clean Energy for EU Island Secretariat, to give you an introduction of what the initiative is, and also to setting the scene to show what the challenges and opportunities for hydrogen in islands are. After this, we will have an introduction of the Green Island project, through which we are having this webinar today. And we will have Victor, the project manager for the project manager at Enagas Renovable, and also the coordinator of the Green Island project, presenting you what's happening in Mallorca. After this, there will be some time for the Q&A, and then we will go through the presentations, the best practices from the islands that we selected. So we will start, as I mentioned, the islands that we picked, the examples that we picked are different in terms of geography, but also in terms of advancement of the projects, because we will start with the Aeolian Islands, Estonian Islands, with Sulev Aloge. He's project manager in the Estonian Islands Energy Agency, and what they are doing in terms of planning, project planning for using hydrogen ferries in the Estonian Islands. Afterwards, there will be a presentation from Erwin de Boer in the Ameland Island in the Netherlands, explaining what they are doing. So projects in development, the hydrogen VAT project, and also the Janos project. So an overall presentation of what Ameland is doing for with hydrogen. And then we will have the presentation from Gran Canaria Islands, and Santiago Diaz Ruano, who is the industrial engineer at the Instituto Técnico de Canarias, will present what's being done, what was done with the remote project, which is completed, and also presenting a new bio-green finery project still ongoing. Again, after you will have the chance to have some Q&As, and then we'll wrap up the webinar. So before starting, very quickly, let's go through the housekeeping rules together, and which you cannot see the. Okay, let me just stop sharing the presentation and sharing again with you the presentation, because otherwise you will not be able to see the content with the transitions. So this is the beauty of the live stream. In the meantime, everyone, please do keep your microphone switched off in order to ensure a smooth webinar. And here now you can see, and also the housekeeping rules, I assume. So a reminder, this webinar is being recorded. Please mute yourself during the webinar, but you can also keep the video on. In terms of Q&As, you can think of your questions and write them in the chat. Please also add the name of the speaker so that we know to whom we will ask this question. Based on the number, we may pre-select the questions. If there will be too many questions, we would need more time to select them. And if the time allows, we may also open the floor for live interactions. In this case, you can raise your hands. For you to know, slides and recordings will be available for you and sent to you within a week. And I think that now we can just enjoy the webinar and start with the first speakers. So I would give the floor to Jan Cornil from the Clean Energy for EU Island Secretariat, and afterwards immediately to Stefano Barberis.
So, good morning, all of you. I'm Jan Cornili, the project coordinator of the Clean Energy for EU Island Secretariat. I'm very happy to introduce the session here today, together with our partner, Stefano Barberis, who has joined the consortium for this third phase of the Clean Energy for EU Island Secretariat. So we're at the third phase. The initiative started in 2018 with a lot of work on clean energy transition agendas. Then there was a second phase in which we also were active as project coordinator, where we did a lot of pre-feasibility studies on different technologies, on different island situations and so forth. And now we are in the third phase where we want to go all the way to fully renewable energy powered islands. And that's the big goal of this third phase, is to prepare to work with islands on projects that would bring us to 100% renewable energy powered islands by 2030. That's a vision, an ambition. We know that there's a lot of obstacles on the way there, but our goal is to work on these obstacles together with the island communities, together with experts, together with developers and investors, in order to make sure that we are as close as possible to being fully renewable energy powered. And there we actually are in the process, in the final process of selecting 30 islands with whom we will work very intensively in the next 3 years towards this goal. And then we will also open up that space for other islands to follow. An important part of our work is on the best practices on connection policies and management of energy systems, and that's already also where the hydrogen potentially comes in, and to be a platform of exchange of good practices and so forth, which we do in our annual forums, but also in a series of workshops that we will organize. Who are we? We are, as a secretariat, a consortium of players from all over Europe. We have, on the one hand, the consortium members who organize the different work streams, the different tasks, and are taking care of or putting their expertise in support of these island energy transitions. And we have regional partners from most of the island nations of Europe, of the European Union, with whom we work then more specifically on a set of islands locally. You see them all here on the screen. I'm not going to name them all, but you can obviously check all that information on our website. Why are we aiming towards 100% renewable energy islands? Well, for a start, it's European law. We want to become carbon neutral by 2050. Now, this target is by 2030, so we are actually speeding up and accelerating on the islands because we think there's a number of elements that actually make it beneficial to go faster. One is the abundance of renewable energy on many islands, where we can go for a more rapid and complete transition and set an example. But also it is fitting for island communities to cooperate on, to co-own, to co-manage renewable energy assets and make it part of an increase of quality of life and economic development. It is also, we know that energy provision to the islands has always been insecure in a way. In continental Europe, we are now facing the situation where the pipelines are no longer giving gas, but the pipelines were never there on the islands anyway. So most of them, with some very few exceptions. So we are starting from this energy insecurity point, and there locally produced renewable energy can actually be beneficial towards that goal. And we think it is a community project. It's part of the tradition of the Clean Energy for EU Island is always to have worked from the bottom up, from the island communities, working together and taking in hand the energy transition locally within the communities. So what will we do? Well, obviously, it's a vision, it's a guiding principle, but there's a lot of actions under that. And the actions are obviously to do with energy production and consumptions, but not only that. It's how the renewables find their way into our lives, in our transport, in our heating and cooling, in obviously our power consumption, and in our agricultural and industrial practices. And that's where we want to think through the priorities, the challenges, and the needs that every island is facing, some of them common, some of them individually. Not every island has the same challenge, and so we work tailor-made on the level of the islands. And we obviously are looking for results. We don't only want to lay out the maps and the agenda and do the preparations. No, we want to work hand in hand with the communities to realize projects on the ground and do that in a very structured way. So where does the hydrogen come in? It comes in two tasks which are central to our work. The first is the support for the 30 islands, which we are in the final phase of selecting. And that's where, when it comes to storage, when it comes to heating and cooling, when it comes to powering transport, we will be working with hydrogen. And the second is on the study on interconnected grids, where again, we are looking at all the different measures that can stabilize a grid, that can reduce storage, that can make sure that the quality of life with a fully renewable energy system is guaranteed. And you see here the different steps. I'm not going to go into them in detail, but there's a place there potentially for hydrogen, and we'll be very keen to hear about some of these examples here. So this is as a sort of general introduction from the Secretariat. I now hand over the floor to my colleague, Stefano, who will go into more detail into hydrogen for islands. He is he and the organization is our hydrogen experts within the consortium. So thank you very much for your attention, and I'm very happy to answer any questions later.
Thank you, Jan, and good morning, everybody. First of all, as Jan said, I'm Stefano Barberis from Blue Energy Revolution. Our role in the technical team of the Secretariat, Clean Energy for EU Island Secretariat, is actually the hydrogen expert. So I'm very glad to be here today to present which could be the challenges and opportunities to promote hydrogen on islands, as well as to take a look to some projects later on that are already ongoing. So in principle, hydrogen for island could be a game changer, could be relevant opportunities for different reasons, mostly because, as you maybe know, hydrogen technologies are maybe particularly in such cases not so mature, so island could become living laboratories also for mainland application. The fact that we have high cost of fuels and high cost of energy on our European island that could facilitate the introduction of expensive solutions and expensive hydrogen, because we have to admit that today hydrogen is expensive, as well as Jan already mentioned, the possibility that missing an energy infrastructure like interconnection with mainland or presence of natural gas grids could become, a fertile ground to promote hydrogen as, let's say, fundamental energy vector for these new hydrogen islands. Also because in islands, as we are promoting with the Secretariat, we could have a large amount of renewables thereby produced, and we could also, thanks to power to hydrogen, so hydrogen as a storage solution, deals with the mismatch between the seasonality of the demand, particularly in touristic islands, and the overall along the year production coming from renewable. So if we try to make a SWOT analysis of using hydrogen on island, of course, we have some points of strengths, like the fact that Islands has a strong renewable potential. Islands are, of course, island mode if we look at them as grid solutions. But at the same time, there are weaknesses, like the fact that we are missing energy infrastructure. This could be both a pro and a con. The fact that islands sometimes are small or can not welcome so many potential off-takers of hydrogen. We will see later on that the role of off-takers is crucial to promote hydrogen in any type of application, but I would like to say to develop ecosystem of hydrogen production and usage. Also, the issue of freshwater production and freshwater needs, that is an issue, let's say, generally speaking, for population living in island, but could be increased by the needs of freshwater for electrolysis. But at the same time, we have also opportunities like the possibility to use hydrogen, as I said, for demand seasonality mismatch, as well as the fact that it could be easier to create ecosystems of producer of hydrogen and users of hydrogen, as in Ireland we have a restricted community where it could be easier to engage all these stakeholders. At the same time, we have to consider that hydrogen, as I said, is expensive. So even this high cost could not be competitive if compared when the high cost of fossil fuels, and the fact that, of course, today there is a risk of social acceptance for all the hydrogen technologies. As I said, one of the main issues when we would like to try to develop a hydrogen ecosystem, so an area where I can produce and locally use hydrogen, is the potential missing of off-takers, particularly when we look at relevant and bulky off-takers, so off-takers that can require a large amount of hydrogen. We obviously look at industrial application that could make this hydrogen already remunerative today. And if we look at islands, it's not so common, except for larger islands, to have large industrial sites or hard-to-abate industries, for example, that could be the first off-takers for hydrogen. At the same time, if we look at logistics and vehicles, again, this is something that we could miss on island. Another aspect is that we could not have, for example, in all islands, the availability of an infrastructure like a natural gas infrastructure that could be used as a backup for example, injecting the produced hydrogen in a natural gas grid where we can circulate the hydrogen along the island. This is something that we will see later for Green Hysland project, but not, for example, all European islands have these natural gas pipelines. And last but not least, also the needs of renewables, because, okay, we know that to produce green hydrogen, we can take advantage of the large renewable potential of island, but not all the islands could install this amount of energy. And of course, even today, it's challenging to have 100% renewable driven island. If we would like to have green hydrogen production on site, we must have even more renewable to be installed, because we have to self-produce our own hydrogen. So let's say, again, this is something that could be an opportunity, but could be also a risk. Particularly, this could be a risk if we would like to handle our hydrogen as a long-duration electricity energy storage. At the same time, this is something that we can take into account if we would like, as I was stating, promote the paradigm of the 100% renewable hydrogen. We have, in any case, to consider that, generally speaking, when we would like to promote a hydrogen ecosystem, a hydrogen economy in an area, in an island or in a district, in a region, practically the power to hydrogen to power is not the best option to, let's say, install electrolyzer and exploit our renewable. Why this? Because the overall value chain of this storage in terms of round-trip efficiency of the system is quite low. So in any case, if we look at islands that are particularly fully disconnected and could have a large amount of renewables thereby produced, let's say seasonality, seasonal storage, and the possibility to use power to hydrogen seasonal storage could be a way to proceed. Also because we can have a large scale storage quite site independent. I put a question mark because, of course, when we deal with large size of hydrogen storage, yes, it is site independent if we compare it, for example, to pumped hydro, but at the same time, if we are in an island with a high density of population, sometimes it's not so easy to find an area with safety distance, with regulatory, let's say, aligned to regulatory constraints where we can install a so large power to hydrogen production plant. When we talk about hydrogen projects, let's say, and creation of hydrogen economy and ecosystem, we, particularly in Europe, we are often hearing about Hydrogen Valley, but can we implement the same scheme, the same approach of an Hydrogen Valley in an island? So can we copy and paste Hydrogen Valley and state, okay, let's create a hydrogen island? Well, from a certain point of view, yes and no, because most of all, when we think about hydrogen valleys, we think about an ecosystem where we have different off-takers, different sectors that are targeting to decarbonize themselves thanks to hydrogen. And this could be the more complicated stuff if we look at an island. And let's say, while the easier part is, of course, to geographically limit the scope and the area where we implement our valley. So, if we would like to compare Hydrogen Valley and Hydrogen Island, there are some pros and cons, like, as I said, the limited number of off-takers could be, from one side, a pro, because it could be easier to develop the business model, easier to get permits, if despite looking at an hydrogen valley where maybe I have to interact with different municipalities, for example. But at the same time, having a limited number of off-takers cannot make my hydrogen valley in an island remunerative. The lack of energy infrastructure could be a plus and a minus, because again, I do not have any, for example, gas grid where I can inject my hydrogen, as I said, but at the same time, the fact that I'm missing an electric interconnection could make me using my electrolyzer as an energy storage. Furthermore, okay, we are lacking industrial consumers that, as I mentioned, are the most relevant, particularly in short term, the most relevant off-takers for the produced hydrogen. But at the same time, we can have inside islands an easier implementation, for example, for island internal mobility of hydrogen and fuel cells vehicle. And at the same time, we can have inside the island some specific areas and districts, like, for example, ports, where we can more easily implement, if compared to mainland, our hydrogen solutions. So if we look at what has been defined as hydrogen valley archetypes, particularly looking at short-term horizon, of course, we can think that hydrogen island could tackle the archetype of the small-scale mobility center hydrogen valley, where we have a 1 to 10 megawatt local electrolyzer capacity, targeting mostly the production of hydrogen for a local value chain of vehicles like transports, cars, for example, waste collection trucks. And let me say, in this case, the possibility to work in a closed environment could make easier also the promotion of hydrogen vehicles in the island. So, generally speaking, according to my brief presentation, we can understand that we can have two horizons for hydrogen promotion in Ireland. From one side, what we can state short term, well, we should target mostly the possibility to implement hydrogen projects as, for example, R&D Living Lab and internal mobility. And when I say internal mobility, I also target, for example, short sea transport ships that could be ships that operate among archipelagos islands or between short distance island mainland, or the possibility to also develop low carbon heating in an island, even if, as we know, let's say, better to use other type of heating, low carbon heating solutions, like, for example, heat pumps, if we have a good amount of renewables. And obviously, another possibility could be to tackle a local specific business that could need hydrogen, maybe a local industrial production, where that can make our hydrogen production already remunerative today. If we look at long term, of course, we have to think that maybe in the future, hydrogen or hydrogen derivatives could become, let's say, the future fuel for the maritime sector. And in this way, we should consider that our European island can become really a sort of pit stop, a sort of refueling hubs for larger vessels. Because if we would like to promote alternative fuels, hydrogen or hydrogen derivatives in the maritime sector, we have to consider that the storage, the tank of our vessels will be mandatorily smaller than the current one, where a ship starts from Shanghai and arrives in Genova. So in this way, our island could really become, as I said, a sort of refueling station for us. Last but not least, if we look at long term, we can also think about the possibility to start to produce hydrogen in island, to export this hydrogen to mainland. So not only looking at a captive use of the hydrogen on the island, but maybe also looking particularly on less inhabited islands, maybe with large renewable potential, to make these islands as a sort of hydrogen production hubs, also targeting to export. This is something that maybe you already heard about, some artificial hydrogen islands. This is something that, as I mentioned during the latest forum in Sarema, personally, I don't like as approach. But why I don't like? Not because I'm not an hydrogen enthusiast, but mostly because if we would like to create this sort of island hydrogen hubs, we have to put a lot of money. Something like the estimation for the creation of one so-called hydrogen island, like those ones that are currently under conceptual design in the North Sea, is $34 billion. So, at my eyes, why don't we take advantage of the existing natural one? Why don't we start to think, particularly in particular areas like the Balearic of our Green Island project, or the Orkney, where we have a huge renewable potential? Why don't we start to think today already, looking, of course, at long-term scenario? Why don't we start to think today already to use these islands, as I said, as a sort of hydrogen production hub? I hope this has been good food for thought. I leave my email if you have any curiosity or question.
Thank you very much for this overarching presentation on the pros and cons of hydrogen in islands and all the specifications that you made. You mentioned the Green Island project as well, so I would invite Victor to take the floor with the presentation of the project.
Yep, I'm here. I will share my screen. One moment. Let me 1 minute. I think you can see it now, isn't it?
Yes, we can.
Okay. First of all, thank you, Christian, and thank you, Federain, for organizing this webinar. I think is really interesting to promote this type of meetings, of webinars. So thank you very much. Hello all, my name is Victor Encinas. I'm the project coordinator of the Green Hysland project. Yeah, I'm here to let you know more about the project, about our project, and yeah, to let you know which is the key elements, the lessons learned, and yeah, to talk about it. Okay, so I will start. Sorry. Yeah. Okay. Today, hydrogen is already being postulated, as you already know, as the key of one of the key energy vectors for achieving the decarbonization of the planet and meeting the commitments set for 2050 in the fight against the climate change. However, and although this key important element today, there are some questions about the viability of the green hydrogen due to mainly the high production cost, technical issues, and that's point. Reasonable or not doubts will be reduced as technology advances and as more and more projects become a reality and are commissioned. So in this sense, the Green Hysland project arises, a project that combining public and private collaboration, which is key important, will shorten the learning curve of the technology, including all aspects related to production, transport, distribution, and use of green hydrogen. Thanks to the project, it will be possible to reduce the hydrogen green gap, the gap between the production cost and the price that the off-takers want to pay, and gain experience in the processing of a completely new industrial activity. This completely new, relatively new sector. Furthermore, the project will allow and is allowing currently the acquisition of some technical and operational skills in the execution and management of this type of projects, which, in absence of companies with extensive previous experience, is highly relevant when carrying out, for example, an EPC of a plant. In other words, the project is an excellent way of acquiring knowledge and experience, which is really essential for developing larger projects in a near future. Okay, in the next slide, I would like to show you the general outline of the project, which revolves around the hydrogen production plant, which is located in Lloseta, a town located about 30 kilometers away from Palma, and built under the umbrella of Power to Green Hydrogen Mallorca, which is an SPV created for this purpose and for the management of the plant. Once produced, this hydrogen is then transported via tube trailer and hydrogen pipeline to the different location, to the different end users, where we find three main end users: injection into the grid of the natural gas, supply to both public and private sectors in a mobility point of view, and the stationary uses through the installation, through the deployment of three fuel cells. Okay, in the next slide, I would like to show you the location, the specific location of these key elements in the island of Mallorca. In the map, you see the hydrogen production plant, which is, as already mentioned, is located at Lloseta, which is a town near to Palma. And then we have the main end users that most of them are located in Lloseta. To connect these 2 points, we use these tube trailers to transport the hydrogen, and the hydrogen pipeline to connect with the point of injection in the natural gas grids. So, as I said, the core of the project is the hydrogen production plant, whose first stone, which is important to mention, was led thanks to the collaboration between the agreement collaboration between Enagas Renovable, Acción Energía, IDAE, and CEMEX, which through the SPV Power to Green Hydrogen Mallorca have made investment in 2 PV plants, which together have 14 megawatts of solar PV energy, and in the electrolyzer located in the hydrogen production plant that currently has 2.5 megawatts of electrolysis. This allow the production of more than 300 tons of hydrogen, green hydrogen per year, a facility that for sure will be scaled up in the future. Okay. As already mentioned, this hydrogen, once produced, is transported by tube trailers, which are already a reality. These 2 tube trailers are in the plant of Lloseta, and that allow transport the hydrogen in a suitable pressure and conditions to the different end users location, where we find the mobility uses thanks to the installation of a hydrogen refueling station in the bus depot of the company that is in charge of this part, which is the EMT company, that is a public company that is in charge of the public mobility in Palma. And also important to mention that they have already 5 buses in the island. This use also includes the supply of hydrogen to light vehicles for leasing. Then we have the stationary uses, thanks to the installation of 3 fuel cells, one in the Hotel Bahía Iberostar of Palma de Mallorca, the second one in the municipal sport center of Lloseta, this town in which the production plant, the hydrogen production plant is located, and the third one in the port of Palma. Okay, finally, the third of the uses, the injection of green hydrogen in the natural gas network through the construction of a completely dedicated pipeline that will allow transport the hydrogen to the injection point. In this sense, it is important to mention that this pipeline is already under construction. All works has already started and will be a reality at the end of the year or beginning next year. Okay. In this way, thanks to the novelty of deploying a project such as this one, such as the Green Hysland, which cover the entire value chain of the hydrogen, the project will make it possible to acquire a series of skills that are useful today, given fundamentally this lack of companies with previous experience, which is a key point that should be highlighted. Among the lessons learned, we can highlight how to improve this green gap of the green hydrogen, with many financial factors impacting the project and reducing production costs. Another important point, another important aspect is how to process from an authorization point of view, from an administrative point of view, an industrial activity that is completely new, not only for the promoters, but also for the administration. This is a key point that in which we are learning really in this project. But not only ours, but also the administration. And finally, and not less important, I can highlight that thanks to the project, we are learning how to carry out an EPC of this type of project, which, as I mentioned, in absence of companies with previous experience, is being very challenging and is quite important. Okay. All this could not become a reality without the team that is behind the project, a consortium which is made up of 32 partners right now, and that comes with the support of Power to Green Hydrogen Mallorca, which is one of the partners of the consortium of the project, and the companies that are behind this SPV. This consortium is a multidisciplinary and well-balanced consortium, counting with university profiles, research centers, public companies, and private companies. Thanks to this multidisciplinary team with both national and international partners, the project will generate a greater impact in the European community, being able to highlight maybe the clear commitment for the development of a hydrogen ecosystem that is clearly replicable. In fact, in the project, we are carrying out different studies of replication of this model in other European islands and also in other territories such as Chile and Morocco. Thus, the Green Hysland project will provide a blueprint to Europe for the decarbonization of the island economies, and also will serve as a model, as an example for future projects that for sure will be a reality in the near future. That's all from my side. Just
thank you very much,
Victor,
Victor, very much for this presentation of the Green Hysland project, thanks to which we are here organizing this webinar. So we're slightly running out of time a bit for the questions, but we will have another sections of Q&A. So if you have thought of any questions that you would like to speak to ask our speakers so far, you can write them in the chat. And then there will be chance also in the next session for our speakers to answer those questions. Or if they are easy, I invite also the speaker to directly answer these questions in the chat. Very quickly, there is one question that was not addressed and that was asked in the chat. It is about, probably it's addressed to Jan, I'm not sure about that, but it's about the benchmarking that you are doing and planning to do across the projects. Is it at the beginning? Is it something
yes,
that
Thanks. I saw that question, and I also quickly answered in the chat already. So as said, we are now in the process of selecting 30 islands with whom we'll work towards 100% renewable energy. Some of these will include hydrogen as an option to further assess and plan and prepare for in their trajectories. And those islands we will bring together with other islands that have already experience in hydrogen in a workshop that will exclusively focus on the development of hydrogen on islands. And I think we don't have a benchmark at the moment, but it could be a very good goal for such a workshop in order to establish one and establish the template or review the templates that we've also just heard of for the use of hydrogen in islands. So that's my short answer there.
Thank you very much. Okay, there is also another quick question in the chat about the water needed for in terms of to produce 300 tons of hydrogen. And other questions are arriving. So I would
just to give a flavor, to produce 1 kilogram of hydrogen, I need 9 kilograms of water. So you can make the multiplication. So we are talking about 2,700 tons of hydrogen. Of water, sorry.
Already respond. Thank you.
To have experienced hydrogen experts here crunching numbers so quickly. Okay, I think that we can now, if there are any other questions, again, there may be chances for addressing them in the next session of Q&A. And without any further ado, we can start with the presentation from our best practices selected today. I would give the floor to Sulev Aloje from the Estonian, presenting the Estonian Islands project and what they are planning to do in order to have hydrogen ferries in the Baltics. So I give the floor to you.
Thank you, Kristin. I'm happy to welcome you on behalf of the newly established Islands Energy Agency from northeastern corner of European Union. Many of you hopefully visited us in June this year when Jan's team arranged another energy forum of European islands. So we have been selected by Clean Hydrogen Partnership to be one of the 15 regions getting project development assistance throughout this year to work out our hydrogen roadmap on the archipelago consisting only 45,000 inhabitants. To give the context of our situation, then very often when the new marine grid for electricity by countries surrounding the Baltic Sea has been shown, you see that the connection to our two bigger islands, Saaremaa and Hiiumaa, is not there. So what we would like, how this scheme would change, is in that way where the connection, as it is planned in North Sea, as it is planned in the south of the Baltic Sea around the island of Bornholm of Denmark, so that also our islands would become a hub connecting Finnish, Estonian, Latvian, and Swedish electricity systems. When we look on the hydrogen backbone plans of drawn by European Commission to connect across the countries, then we will see another challenge. First planned hydrogen backbone going straight from Finland through Baltic states towards Poland is not covering islands, and as we just heard, that one of the options for islands would be also hydrogen production sites for mainland, then it will create for us another question how to get the hydrogen from the islands to the biggest off-takers on mainland. After mapping in the hydrogen regions program our main opportunities, we realized obviously the first chance is to look towards transportation system. This is the number of vehicles which can be converted to use hydrogen as a green fuel instead of currently used diesel. And we have divided the process into two phases. First of that nicely aligning with the initiative taken by Clean Energy for EU Islands. The investments are huge, and therefore we think it requires us to be realistic in terms of especially off-taker side to be ready to purchase, to invest in hydrogen-powered fuel cell carrying vehicles. We have on our bigger island next procurements for public buses planned for 2030, which makes a perfect match to be ready by that time supplying hydrogen in order to give the opportunity to island authorities to go for hydrogen solution for the next contract term. The big question is how to get hydrogen to ports if we want to combine bunkering and refueling. Then ports will be the most logical site doing this, but the port close to the center of our biggest island is a good example where actually just 500 meters from that site runway of the airport ends, and there is no way to be to install a windmill there. But in our Nordic climate, without wind energy, electrolysis wouldn't be all year round possible. So therefore, we need to also find innovative location-specific solutions how to deliver hydrogen to the ports where the full chain cannot be installed on site. This year, our national government introduced a pilot grant scheme where we made some efforts to submit the application, and this was based on our shipyards' will to use their investments into both wind and solar energy so that the excess energy of that installment would be utilized to supply Estonian-produced electrolyzer, which in connection with the by the composite pipeline would supply then a hydrogen refueling station for buses and refuse trucks, which we cooperated for that pilot application. And then the port shown would further on have been supplied by special tube truck or pipeline extension. Unfortunately, we were not successful in finally submitting the application. What were the reasons for that? The national call introduced by Estonian government required due to sources of that program from European Commission that electrolyzer should be already up and running in 2 years' time, and it is quite complicated, as even the regulation by the national government is not in place. And when I discussed the initiative with my foreign partners, especially from Netherlands, they were quite surprised, saying that permitting of full chain of hydrogen in 2 years' time would be a very big challenge. The grant offered was covering only capital costs, and this was the main challenge, preparing the Excel mathematics to make the project feasible. 1 month before the submission deadline, 2 bus operator partners who have been delivering buses for them throughout their cooperation said they unfortunately won't be ready by 2026 to take over all the risks and make sure the maintenance will be in place. Also, European requirement for additionality of requiring that electrolyzers should be supplied fed in by the electricity only by maximum 3 years old wind or solar energy installments is a big challenge, because our government's grant scheme for that part, for renewable energy generation, no grant was provided. Inside Estonia, we haven't reached the final decisions what the strategic locations for these hydrogen generations and bunkering for ferries would be. We feel a strong pressure from the powerful energy companies on mainland side to start delivering on mainland side, which means that part of our projects wouldn't be available on the islands. For us on Estonian islands, key trigger remains ferries. The ferries form stable all year round demand, and the way forward is that the electrolyzer ports for ferries will be slightly oversized, so we can attach to them also public buses, refuse trucks, and other vehicles. So looking towards 2030, our government is about to call the tender for designing and construction of the new battery hydrogen ferry. We're planning retrofitting some of the running ferries to hydrogen, and we also need a replacement ferry, which then serve also our smallest island in Gulf of Riga. We're not only staying with ferries. We in our perspective plans, as it was earlier also mapped, when we look beyond 2030, we look for opportunities like in Portugal. There is this ammonia project. As we don't have enough biomass supply available on the islands, so then ammonia would be the case also on our biggest port, not so much utilized. On the left corner here you see the fertilizer can be next step where to use this ammonia. Challenges are given here, and we carefully follow our Finnish neighbors as they progress with the similar type of projects. And finally, we hope that from these big transportation triggered projects, where ordinary islanders see little touch, we reach up to the point where oxygen as a side product of electrolysis can be used for supporting local aquaculture, where also through fuel cells we can generate heat necessary to turn the island's biowaste into protein-rich feed for, again, fish and chicken. Their leftovers feed green production, which is the source for island tourist sector needed food sector. So thank you for your attention.
Thank you so much, Sulev, for this overview. If you have any questions for Sulev, please write them in the chat. There will be chance later on for the answers. I will now invite Erwin to speak, to share the screen and present what they're doing in Ameland.
Thank you. I will share my presentation. So I think it's on the screen now. I will tell you something about the island of Ameland. I work for the municipality as a technician. Ameland is located on the north side of the Netherlands. You see a picture of Google now. We do have a grid connection to the mainland. I think we're a quite small island. We have 4 villages, 3,700 inhabitants, and we have a lot of tourists a year. As you can see, we have 1,800 homes for the inhabitants of the island, and we have over 2,000 holiday homes. So that's a bit of well, equal in numbers. The Netherlands have a goal, a climate goal of 95% carbon dioxide reduction in 2050, and we want to get to that goal 15 years earlier. So that's quite a big goal for a small island. We have a history. We started in 2007. We built a consortium and we started doing small projects. There was a local energy cooperative founded, and we started doing a project with our inhabitants. The buses, for example, they started driving on natural gas, and now they're electric. So there's been 2 changes in well, I think in 10 years. Here are a few projects which we did with our inhabitants. We try to involve them as much as we can, so that if we start a new project, everyone on the island thinks it's a good thing, or they can say they don't want to do it. We listen to them. We have 2 main streams of projects. So we have the smaller projects with the inhabitants, which you can read here. The sheets are shared after the presentations. So you can read it on your own, who is interested. The big projects is the other stream. This is an example. It was at that moment the biggest solar park in the Netherlands. In 2016, we built it together with the energy corporation, the local energy corporation, and Eneco. Eneco is an energy supplying company. And we are about to build a new solar park, which you can see here on the picture. I have another picture coming. Our plan is to build energy roundabout in this area. So you can see a few assets on the left side, which I hope we can build in the near future. We call this the energy roundabout because you can put in a form of energy like electricity from the solar park, for example, in the roundabout. You can store it in the battery on the left side. You can put it back in. You can make hydrogen with an electrolyzer. You can well, you can do tons of stuff if you get all these assets combined, and that's our goal. We're building a virtual power plant in the Janos project. It's a European project which runs another 2 years, I think, and we can connect all the assets to the virtual power plant, which will then make the decisions whether to fill the battery storage or make hydrogen, make the important decisions to stabilize the energy network. This is a flow chart of the same system. You can see on the left side there's a solar park with a battery. The construction starts in the first quarter of the next year, so in a few months. We have to build it step by step. So we start with the solar park and the battery. So we have our solar electricity, which we can use to feed the electrolyzer in the near future. We will start with an electrolyzer, small one, 50 kilowatts. It will also be in the 3 or 4 months we can do our first tests. But we're looking forward to get a bigger electrolyzer to make a difference. On the right side, on the top, we can see a fuel cell, which we tested, fuel cell on hydrogen, which we tested in the fourth quarter of last year. We had it for 6 weeks. We'll come back to that a little later. A problem we have is grid congestion. It's all in the Netherlands. We have quite a light electricity system because we use a lot of natural gas. All the solar parks that are producing the electricity are on the same moment. So we have a lot of peak production in the middle of the day. You can see on the left side, this is during the day. There is peak demand in the morning and a peak demand in the evening. But the solar peak production is on the middle of the day. So if we want to make the next step, we have to shift the solar peak production to the evening peak, and we like to take the morning peak with it, so we can get the grid to calm a little down. And you see all the red parts in the Netherlands. They have big problems. Companies can't get a new connection. There are all other kind of problems with the grid. In the H2Watt project, which is another project, we made a model which makes a calculation of the technical aspects of such the energy roundabout. So you fill in how many solar panels you got, the hours, and it will count how many tube trailers do we need to get enough storage to get the production for a day or maybe a week, whatever you want. It will calculate it. And it also has a business case attached. So in the test with the fuel cell, we could validate this model, and it came out quite good. So it's something we can share in the near future. But this is the test site of the H2Watt project. You can see on the smaller unit is the fuel cell, which is a 110 kilowatts fuel cell on hydrogen. We bought some hydrogen in the tube trailer, which we used for 6 weeks. The do's and don'ts. Starting time. Different laws, natural laws, permits. It took us a year to do a 6-week test. So starting time with everything you want to do. It's all new and it's hard to get through. The transportation of the hydrogen to an island is quite hard. We had to book a ferry that only took the tube trailer to the island. No one else could be on the ship, so it was quite a thing. You need companies that think along. It's quite a process, and you need to do it together. So that's what we what we think it's very important. Don't stop after disappointment. We had to shift from left to right. We have to think of other solutions. It was quite a big thing to get to the final testing site. Don't start too tight. You need space within your organization. You need some room to do stuff. I want to close it off with a small video. It's in Dutch, but it got English subtitles. So I will start it now.
I think we cannot hear. Can you hear me, Erwin?
I'm sorry?
We cannot hear well.
We cannot hear the.
Yes. Maybe you can put the link in the chat, and
I will put the link in the chat.
Perfect.
It's on YouTube, so that's
Let's
better.
do like this.
Yeah. Okay.
It's okay. No worries.
Thank you.
Thanks.
This was my presentation. I don't know if you want to do questions now or later on.
Yes, we do it later. So we are collecting all the questions in the chat. So for the participants, if you have any questions for Erwin or Ameland, please write them in the chat. We'll have a session afterwards. And I now give the floor to Santiago, speaking of what's happening in terms of hydrogen deployment in Gran Canaria, and presenting specifically two projects. One, the remote project's already finished, and the second one, the Green Hysland, which is ongoing. So I leave the floor to you.
Thank you very much. First of all, thank you very much, Federación, for the kind invitation to present this project. As Christian mentioned, we are going to speak about mainly two projects. The first one is a remote project that have finished in July of this year. Also, we are going to present a little bit a Green Infinity project that was finalized too, and are going to be inaugurated tomorrow with the president of the Canary Island. And I think that is also a good opportunity to know this project because it's quite related to all the topics that have been explained today in this meeting. So first of all, we are going to start with the remote project. Remote project is a project that was developed over the last 3 years, in which 3 main demo sites was tested, One of them was in Norway, another one was in Greece, and the last one was installed here in Spain, specifically in Gran Canaria Island, just in the west area of one of the islands that is in Gran Canaria. And in these 3 main microgrids, we tested different solutions, regarding how we can integrate the hydrogen as an energy storage solution in some places that could be a little bit more complex to decarbonize because don't have any kind of electrical connection or have some difficulties. So, for example, the one that was installed here in Gran Canaria was installed in an area that we usually say that is like an island inside another island. It's a geographical island that don't have any kind of electrical connection with other islands. It's one of the islands in Spain that don't have this kind of circumstances. But also inside this island, as you could see, we have different natural protected areas, and that is the reason why we don't have any electrical connection. So if you want to install there a big industry, you will have problems with the electrical connection always. In this case, for example, we have a cattle farm. It's a company that was established there a long time ago. They have near 1,000 cattle heads, and the energy consumption that they have nowadays is big, So when they try to connect to the grid, they don't have capacity to do it if they don't have a diesel genset. So it's something that could be the microgrids could be a good solution as a way to provide not only renewable energy, but also a solution for the kind of services that they need. So in this case, was installed a system composed of different elements. One of them is a PV plant of 100 kilowatts. It's just the one that you could see in roof of the warehouse that they install. Okay. Also, a battery system was installed there of 100 kilowatt, 100 kilowatt hours. And inside the project was installed the different elements that you could see here. For example, the first was an electrolyzer of 1 kilogram of capacity per hour. That means that can produce around 30 tons of hydrogen per year. And they use this hydrogen as an energy storage solution. So they have a hydrogen storage tank of 50 kilograms with the pressure of which they work is 200 bar, okay? And also a fuel cell of 100 kilowatts. So here is important, the integration is one of the key elements, but also how you are going to control, because you only have the PV plant as a energy supply. So the diesel genset, they need to keep this diesel genset for moments in which they don't have other option. But at the end, it's important to apply some control strategies, not only for the real control of different elements, but also to use the electrolyzer as a way to apply some demand side management strategies. So it's something complex, but really useful if you want to increase the size of the energy storage, because at the end, it's one of the key elements inside this kind of projects. So here is the electrolyzer that was installed. In this case, was installed an alkaline electrolyzer. So this kind of solution need a purifier, as you it's possible that know. Also, due to the installation of this purifier, you need a nitrogen generator, also an air compressor, and other system that was all integrated in a container. So it's a good solution for most of the areas in which you could install a platform like this, because you can control there different topics, like, for example, the safety conditions that should have an electrolyzer like this, okay? And also was integrated a system to apply some demand side management to reduce the production of hydrogen when you don't have enough capacity to produce the fuel, okay? Also, a fuel cell was installed here. This fuel cell is an integration of a fuel cell produced by Ballard, but also the integration was developed by Inicom, a company that is here in Spain. And also the inverter that we want to install here was a solution of Norvent. So it's like a system that was designed specifically for this project with different combination of different manufacturers. Okay, so at the end, the core of this solution is the electrolyzer and the fuel cell, but also you need to integrate in an electrical system, and that is maybe one of the big challenges that had to be defined at the beginning of the project. Of course, the reason why the project could be more difficult to implement in real life in comparison with other kind of solutions, for example, with batteries. No? But in general, here you could see the grid that they have, the cattle farm with the different consumption, and also the integration of the different components that should be always controlled by some communication protocols to define when you need to work with the battery or work with the electrolyzer or the fuel cell, a combination of both, or the diesel genset when you don't have other solution. And that is the more complex thing, because at the end that was a real use. It's not a laboratory. Okay, so if they have a problem with the energy supply, you need to provide a solution, and they work 24/7. I mean, if they have a problem at the Saturday at 9, you need to provide a solution in this moment. Okay, and that is maybe the most complex thing in this project. Regarding the communication system, we use a protocol called Modbus TCP. So all the elements that is inside the platform use the same protocol as a way to have a solution that could be easy to manage. Okay, so all the communications was developed by the consortium. The consortium was composed by 11 companies, but specifically the integration in the microgrid of the Canary Islands was developed by Inicom, Capisa, ITC, and Politecnico de Torino as a coordinator of the project. Okay. Here you could see also the different elements of this microgrid, and well, also was installed a SCADA system in which we collect all the information of the system. It's not only the collection of this information, but also how you need to estimate the power that you are consuming each moment, the surplus that you have, the capacity that you have in the future to increase the size of the system. All this information is important, and the SCADA is a key element for that. And well, that is a remote project. The other project in which we are working nowadays, and well, we are finishing, is the BioGreenfinity project. But first of all, we need to say that here in the Canary Islands, it's important to use the hydrogen as a possible solution for the transport sector. Why? Because we try to advance in the electrical sector, but we have problems with the mobility sector. If we take into account all the consumptions in the electrical sector, the load demand coverage is near the 22%. But to tell the truth, if you take into account all the consumption, the global balance is near the 2%, and that is due to the transport sector. No? So here in the energy planning of the Canary Islands have been integrated the green hydrogen as an element for the decarbonization of the transport sector, the road transport sector, specifically with the direct use of hydrogen, but also we are thinking on the use of ammonia and kerosene for the marine and air transport sector. So in this context was installed a platform inside our facilities in which we have two main lines of research. One of them is the direct use of hydrogen for the mobility sector, the road transport sector. We have two hydrogen cars and also a bus in this project. And also we have a line for the production of ammonia. Okay, all this line is now active and tomorrow are going to be inaugurated. In general, the system is the one that you could see here. Okay, we have an electrolyzer of 3 kilograms per hour of capacity. We produce the hydrogen 350 bars storage in tanks, and after that we have a dispenser to supply the hydrogen to the two cars and the bus. The bus are going to work between the location where we are in the east region of Gran Canaria and the south by the local company that work here for this kind of purpose. Okay, and also for the production of ammonia, we have another electrolyzer of 1 kilogram per hour of capacity, a nitrogen generator of 4 kilograms of nitrogen per hour, and the combination of the hydrogen and the nitrogen goes to a Haber-Bosch in which we produce the ammonia specifically for the marine transport sector. And that is the test that we developed. Here you could see the entire system. That is a real picture with a drone. Okay, it's not a model. Here we have the big electrolyzer, also the tanks, 60 kilograms of capacity, the dispenser. This is the other electrolyzer that I mentioned before. We store the hydrogen in this tank, and also we have here a nitrogen generator. We produce the nitrogen and storage in this tank, and finally this is the Haber-Bosch system to produce the ammonia. The ammonia is produced in liquid state and storage in this tank in liquid state for the proposal that I mentioned before. No? Also, we installed this wind farm of 100 kilowatts, a PV plant of 275 kilowatts, and a battery system of 100 kilowatt, 400 kilowatts hour. And all the system work totally isolated. This is a standalone solution. So we test the kind of problems that we have in the Canary Island because we don't have connection with the mainland. Okay. And also here you could see other elements of the system. That is the bus that I mentioned before. one of the two cars. We have two. That's the tanks, the dispenser, and well, it's more or less the general idea of the project. As I mentioned before, it's important, the demand side management, as I mentioned. All the systems are controlled with the same protocol. Here, as you could see, the communication system is a little bit more complex than the previous one that I mentioned for remote project. But in general, it's something that is possible nowadays. The technology is there. Maybe the problem is how to do the proceedings, okay? Was the biggest problem that we have, but at the end, everything works in 1 year and a half. It's the time that we require for the installation of this complete system. And well, that is all. I think that I am in time. Well, thank you very much for.
Thank you very much for this very technical presentation. For the participants, as a reminder, you will receive the presentations from the speakers, so you will have all the time to see details of the of all the presentations, and especially also this technical one. So if you haven't written anything in the chat, I would invite you to do so, because now it's the moment for you to actually ask questions to our speakers. We already have actually one question, which I assume is for you, Santiago, which is about the implementation of having basically e-fuels through green hydrogen. Is it have you implemented any system to provide aviation-ready kerosene through green hydrogen? Since Canary Island is an island, a remote island, maybe that's why the reason of this question.
Well, in our case, we decided to start with the ammonia, and that was for the budget, because at the end the budget is a limit. So we start. The system is complex and also expensive. Okay, but if we want to do a further step with the kerosene, we need a Fischer-Tropsch system. We have there a biogas plant that we can use to collect the CO2. Also, with the hydrogen, you can combine a Fischer and Tropsch system, and that is the next step. Okay. Also, we have a gasifier there to produce methanol. Okay. So it's another line that we are analyzing. Also, I don't know if you could see in the picture, we have a specific area for this kind of facilities in the future, but nowadays not. We produce hydrogen, nitrogen, of course, oxygen. We use, for example, the oxygen to improve the quality of the gasifier. Finally, the next step is the kerosene.
Thank you. Hope this answered the question. So to quickly wrap up, we saw different perspectives today. We saw projects that have like at the planning phase from the Estonian Islands, projects that were completed and projects that are ongoing. We've seen how what different geographic islands are doing, and I wanted to ask some questions to also the other speakers based on this specific difference in the advancement of their projects. The first question would be for Sule, because it's still at the planning phase, and at the end, toward the end of the presentation, you mentioned the citizens, how you engaged them and presented to them the technology and gave them a touch of the future, as you said. So I was wondering, in this planning of the planning phase, the way you spoke to citizens, what was the perception of these new technologies, hydrogen, and also you mentioned ammonia, for what was the perception from the citizens' point of view in terms of the planning that the Estonian Islands are undertaking?
I'm afraid the maturity of the perspectives is not enough to present anything specific yet for citizens or for public discussions. many of the challenges I mentioned in my presentation, first of all, should be figured out, worked out in more feasible plans. Of course, citizens would care a lot what will be the ferry ticket or what will be the price of the bus ticket in case diesel is replaced by hydrogen. And that is definitely, according to previous experiences of public discussions and hearings, what do we need to address and show that this green transition wouldn't put any financial additional burden to the islanders.
And it's a good point indeed, like trying to understand how to communicate this to citizens and also making sure that this green transition doesn't add financial burdens on them. I want you also to ask some questions to Erwin in terms of what they are doing in Ameland is very ambitious because the island is planning to reach climate neutrality by 2035, which is more ambitious than what the national government is doing. So I'm curious about who is driving, what are the driving factors that are pushing these targets so quickly in Ameland for the uptake of hydrogen as well within these plants.
Well, one thing is that we're already been doing it for 16 years, so we have a bit of a head start. We started as a hobby, and now we have to do it. And the council of the municipality, they took a stand and they said, well, we're ahead now, we should stay ahead, and let's do it together. Let's get the natural gas off the island and bring the carbon dioxide down, and let's be ready in 2035. So that's my job at the municipality with a few others.
So let's do it together is indeed like a good sentence, because it means that in order to embrace this transition, many stakeholders would need to be involved. If like there is not a drive from the public authorities as well, but also from the national governments, as also Sulev mentioned, like the fact that the regulatory framework at the national level in Estonia was actually hindering the deployment of hydrogen in the islands in some points was also important, and how to communicate these technologies also to citizens to make sure that they are also on board, aware about what's happening. That's also a factor. All these things to kickstart hydrogen projects in islands. I have another question specifically for Victor now. If we kickstart projects in islands, we can, after we kickstart, maybe at some point we would also need to scale up these projects. And scalability is one of the main issues that is one of the main issues in general for projects, hydrogen projects, specifically in islands where territories are also limited. So based on your experience, what should be the way to favor these economies of scales and flexibility in hydrogen projects?
Yeah, this is an important point. In order to promote these economies of scale and flexibility in this type of projects, we should consider different pathways or approaches to consider and focus on this part. For example, we should consider, which is something that we have included in the Green Hysland project, is the integration of multiple stages of the hydrogen production process into a single project. That is, we should integrate all the stages in a single project to have a greater efficiency, a greater economy of scale to achieve this point. We can share different structure, resources, yeah, optimize the process. Okay. Then something also important is the strategic location. The selection of the location is also important as it could contribute to this economy of scale and flexibility. For example, if we choose a location in which the consumption is also included, this is important. Or, for example, as is the case of Green Hysland, if we locate the project, the production near to the renewable energy sources, we are going to reduce transportation costs, energy transition losses, and this also is important. On the other hand, cooperation and collaboration. On the Green Hysland project, we have, as I said in my presentation, 32 partners. So the collaboration and cooperation is really important to reduce mainly risks, but also costs. And of course, the policies and regulations should be really, really important to encourage this type of economies. And don't forget the financial scams. This is also a really good point to be considered in this type of things. Okay, and I think is summary of the points that we should take into account.
Thank you very much. We are slightly on late, 5 minutes late from this, but I hope this webinar was very useful and relevant for all of you. As indeed my colleague Melissa mentioned in the chat, if you want to stay updated also with the Green Island project, but in general, showcasing also your islands projects about hydrogen, you can also join our LinkedIn group and to also have a quick to also exchange what you are doing, what's happening in your islands about hydrogen, and to keep these conversations going. I would thank all the speakers for all your time. So Jan, Stefano, Victor, Sulev, Erwin, and Santiago, huge thanks for your time, your availability in this, and your insightful presentations that will be shared afterwards also with the participants today. And a big thanks to all of you who joined today's webinar for 1 hour and a half. It was very, very intense. Very packed webinar, but I hope it was also insightful for all of you. So I wish you a great day, and in any case, stay tuned with Green Island and what's happening in the hydrogen ecosystem for islands. So have a good day.
Thank you.
Thank you very much.
Thank you very much, and thanks for the
much.
invitation and organization,
Thank you.
Christian.
Thank you. Bye-bye. Thank you. Bye-bye.
Bye-bye.